Hey, Algebra 2. It's Mr. Osborne doing your Brave School. If you are trying to retake the test, you need to complete this ed puzzle before you continue on to actually take the test. Once you've done that, then you are able to take the test. If you're in my class, you just need to make sure you come in and check with me. That can be anywhere from 10 minutes to 30 minutes to an hour, depending on what you need. Just want to make sure that you get all your questions answered before you actually start the test. Okay. So the point of the ed puzzle is to kind of get most of the questions answered, and then the stuff that you're really having a hard time with, then you come and check in with me. Okay. Also, while you're going through this, you need to do this on a separate sheet of paper. Okay. You're going to have questions that pop up. You're going to do those questions. The ones I go over, don't do those. Okay. Only ones that I tell you to do. Don't do every question that's on here. All right. So, and again, put your name on it. Put the date, whatever it is that day that you're doing it, or sorry, whenever you turn it in, and then number them. Keep it organized, just like you're working on a textbook assignment. Okay? All right, let's get started. Okay, now, this one's a little bit different because it has a negative. Okay, so the nice thing about negative numbers, with cube roots in particular, with a cube root, I know that the cube root of -1 is just -1. Because -1 times -1 times -1 is still -1. So you can take the cube root of a negative number. So what I do with these is first, I'm going to separate that negative from the radicand, or from what's inside the radical. Okay, and I'm going to have just -1 by itself. Okay, and then I'll keep the rest under the radical. A to the 9th, B to the 6th, and C to the 4th. Okay? Now what I'm going to do is, first of all, I know that this here, the cube root of -1, is simply just -1. So that one's done. Now I just have to focus on the rest. Okay, so now what I'm going to do is take 240 off here to the side and break it down with my birthday cake, because it's a big number, so I'm just going to break it down. Divide by 2, that's going to be 120. Divide by 2, that's going to be 60. Divide by 2 again. Oops, sorry, not 30. Divide by 2 is equal to 30. And divide by that 2 again. Well, I keep doing that. Divide by 2, we get 15. And the next number I'm going to do here is 3. And then we get 5. And the next number I can divide is 5. And there's my birthday cake candle. So now on the inside, we'll have the cube root of 2 times 2 times 2, let's see, there's 4 2's, times 3 times 5. Now the last problem, I didn't break it down like it did here. I didn't show every single factor. I just made basically I would say 4 2's is 2 to the 4th. But here is just another way of doing it. Now remember, I have an index of 3, so that means I need groups of 3. So looking at these A's here, how many groups of 3 can I make? Well, I can make 3 groups of 3. So I'll do a to the 3rd times a to the 3rd times a to the 3rd, because that's still the same as a to the 9th. And now let's go to the B's. The B's, I can make 2 groups of 3. B to the 3rd and B to the 3rd. And then for the C's, well, let's use black. For the C's, let's actually move this out the way. So I have a little bit more room here. There we go. Okay, for the C's, I have 1 group of 3 and then 1 C left over. Okay, so now let's go through and get our groups of 3. Okay, so we have 1 group of 3 here for the 2's. The numbers, there's no more groups of 3. And now for the A's, I have 1 group of 3 here, 1 group of 3 here, and 1 group of 3 here. Because remember, that A cubed represents 3 A's. It's not just 1 A. It's 3 of them. Okay? And then again, B cubed is 3 B's. B cubed is another 3 B's. And then I have another C cubed. Okay, so now I need to take out, now we need to just be careful and make sure we take out all the different factors here. Okay? Let's not miss any as we're doing this step. So first, again, we have -1 on the outside already. That's already there. We're going to take out 1, 2. Then we're going to take out 1a. We're going to take out another a, and then another a, because we had 3 groups of 3 for the a's. So we have 3 a's out. And then we have 2 groups of 3 for the b's. So that means we have 2 b's that come out. And then 1 group of 3 for the c's, so 1 c comes out. Okay, so I'm doing this kind of one step at a time. And then what I have left over is this 2, 3, and 5. So that's 2 times 3, which is 6, times 5, which is 30. And remember, don't forget your index. And then the last variable, c. Okay, so now let's combine all these variables that we have out here together. Okay, so now we have negative. Well, that negative 1 is just going to turn everything negative, so we'll just write negative. 2, and they have 3 a's, so that's a cubed, 2 b's, b squared, and 1c. Times the cube root of 30c. Okay? Okay, so this one I'm going to go through a little bit quicker. Okay, again, draw your table, x and y. Then you're going to put your function up on the top, and don't forget there's a negative here this time. And remember, what does a negative do? What does a negative do to any function when it's on the outside? It causes a reflection. Okay, it causes it to flip. So it's not. So I'm going to have to expect that my points are going to make my graph. Usually my graphs go off in this direction, right? If it flips, well, that means it's going to go off in this direction. Okay, so I should expect to see my graph do something like that. Okay, so again, negative, and I want my first value on the inside to be 0, minus 5. You can set it up like this every time. Okay, negative square root of 1 minus 5, negative square root of 4 minus 5, negative square root of 9 minus 5. And again, you can almost just substitute these perfect squares for whatever's inside the radical, the radicand. Okay. Okay, so my first value, to get 0, I would have to plug in 2. And then take the square root of 0, which is 0. And that's, don't forget the negative times the negative. Well, negative doesn't change 0, so then it's just minus 5. Okay, then the next one, to get 1 on the inside, I'd have to plug in 3. And then the square root of 1 is 1. But then it becomes negative because it's negative here. And negative 1 minus 5 is negative 6. Then here I'd have to plug in 6 to get 4. 6 minus 2. And the square root of 4 is 2. And that becomes negative. So negative 2 minus 5 is negative 7. Then here I would have to plug in, let's see, 11. And that obviously I know won't even fit on our graph because the x value of 11 is out here. Okay, that won't fit. So I'm just going to use the first 3 values that I found here. These values here. Okay, so let's start with the first value, 2 and negative 5. So that's going to be down here. And then the next one is 3 and negative 6. And then the last one is 6 and negative 7. So I'm going to do my best to make my little curve. It goes off in this direction. Now it doesn't look the best here. Alright, now I need to find domain and range. Okay, so let's start with domain. Okay, so I come in from the left, and it looks like I hit a point, so I put a bracket. And as I come in from the right, I hit an arrow, so that's going to be a parenthesis. So the number on the left with the bracket is 2, the x value. And I hit an arrow on the right, so that means infinity. And the x values going to the right are positive. So I will put positive infinity with the parenthesis. Okay, and then for the range, again, start from bottom to top. Okay, so from the bottom, looks like I hit an arrow first here at the bottom. Okay, so that would be a parenthesis. And then on the top, looks like I hit another point, a point here, that same point again. And if I hit a point, I hit a bracket. And so I'd start with the bottom and with a parenthesis. And we're talking about y values now because we're range. And the y values going in the downward direction are negative. So that is, oops, sorry, that's a bad infinity. So that would be negative infinity. And then on the top, we'll have, let's see, the y value there at that bracket would be
negative 5, and I put a bracket. Okay? Now it says create a function that has the following characteristics. Translates 2 units to the right and 4 units down. Okay, so remember with any function, don't forget we always need to start with a label or a title for that function, and I'm going to call him f of x. That's the one we're used to the most. Okay, so f of x equals something. Now, let's start with the first description. It says 2 units to the right. Okay, now remember, we're dealing with radical functions. So go ahead and write your radical. And it says 2 units to the right. And remember, x is a liar. X is a liar. So if it goes to the right, that's in the positive direction. Okay, so if we're going in the positive direction, x is a liar, it's going to be x minus 2. And if it's going down, up or down, that changes what we do on the outside. In this case, it's going up. It's going down. So that would be minus 4. And that's it. Okay, next one. So here, again, start with f of x. Don't forget this. Okay, you can't have a function without a title. And then equals. Now it says a reflected across the x-axis. Remember, a reflection occurs when there is a negative in front of the function. Okay, so then that means we need to put a negative in front of our radical. And then it says translate 3 units to the left. Well, that means we're going to the left in the negative direction. If x is a liar, we're going to do x plus 3. And then it goes 1 unit up. So on the outside of the function, it would be plus 1. Okay, and there we go. Okay, now the next one. Okay, now this one is stretched by a factor of 2. Goes 1 unit right and 8 units up. Okay, so again, first start with f of x. Or you can use y. Let's just change it up for the sake of things. We do y, because remember, it's the same thing. It's just the title of a function. Now it says stretches by a factor of 2, a stretch. Well, just remember, if we cause a stretch, okay, and we're talking about a vertical stretch in this case. I should say vertical stretch. And we would say that on the test. A vertical stretch, then that means we're going to change the outside of the function. We're going to change, let's say, for instance, the number that's right here on the outside. So if it was some random, let's say 3, this would be a stretch by a factor of 3. Okay, a stretch is caused by when that number, we'll call it a, so that we can say this is actually a. When that number is greater than 1, it causes a stretch. When a is less than 1 or greater than 0, but then less than 1, in other words like a fraction, then that will cause a compression. Okay, that will cause it to compress this way. And greater than 1 causes a stretch going this way. Okay, so here it's called stretching by a factor of 2, so we simply write 2. Okay, and then your radical translate to the right 1 unit. And remember, we're going in the positive direction, so x is a liar, be x minus 1. And then 8 units up, well, that's just plus 8 on the outside. Okay, now let's just say this was a compression. Okay, it was a compression by a factor of 2. A compression by a factor of 2. Well, then you would write y equals 1/2. Okay, 1/2, and then the same thing, x minus 1 plus 8. Okay, because basically, compression, you put that number over 1 or under 1, and if it's a stretch, it's just the whole number itself. Okay?
Okay, so now in this next one, we want to rewrite this expression in a radical form. So if you look down here at the exponent to this x variable, the 3 itself is our index, and then the 5 is going to be the power of our radicand, or the power of the entire expression when we rewrite it. We can write it 2 different ways. Okay, so first, let's just write our radical symbol, and then let's start with the index, which is 3. Remember, the index is always the value in the denominator of the fraction of the exponent. And then we'll write x, and I can write this two ways. I can write this parentheses raised to the fifth power, x to the fifth. And remember, whatever this value is here, or expression, make sure that you're paying attention to what the exponent or the power is applied to, because it might not be applied to one of the values here. Say there was a 9 here. Okay, so, or you can write this again, the 3x, and then parentheses around the entire expression, raised to the fifth power. And I find that for us, this is more useful, especially when we get to simplifying the expressions later on. Okay, again, 5 is our index, 6 is our power. Okay, so write this in radical form. We'll first write the radical. The index is 5, and then we're going to write 4x, and here's where it becomes important on how you write out the power. Now, if I write this raised to the sixth, just like it is now, what this is saying is that x is raised to the sixth power, but 4 is just 4. It's not raised to the sixth power. So that is why we need to write parentheses around the 4x. Now that sixth power applies to both the 4 and the x. That's the difference. And again, you can also write this, the fifth index, or fifth root of 4x, and then you can apply the exponent to the outside of the entire expression. Okay, and again, I find this a little bit more useful, but on the test, if you answer this like that, you'll still be correct. Okay, so now we're going to have to write this in exponential form, so we're going to do the reverse of what we just did. So again, pay attention to the index and the power here. Now, again, you need to be very careful here, because if you look, this 9x is not in parentheses. So in other words, this 5 only applies to this x. The 5 exponent does not apply to the 9. So we need to be careful with that when we rewrite it. If there were parentheses here like this, that 5 would apply to both the 9 and the x. So when we write this, we're going to do 9x to the fifth, and that in parentheses. Okay, raised to, well, now the power of this whole 9x to the fifth is just 1. So that would be the 1 on top of our fraction, and then below would be our index, which is 4. Okay, again, writing in exponential form. Now if you notice, that exponent here is on the outside. And there's another exponent here on the inside, this 2, but again, that only applies to this x, not the 2. Okay, so now we're writing exponential form. So first let's write our expression, or the radicand under the radical. Let's put that surrounded by parentheses. And then again, we've got our power and our index here. And our power is going to be 6, so that goes on top. And then our index is 3, so that goes down right there. Now if you notice, 6 over 3, just like any other fraction, we can actually simplify or reduce that fraction. And now, 6 over 3 is also 2. 2x squared squared. Okay. And if I was asked you to simplify it, you could go further and apply this squared to the 2 and to this x squared and get 4x to the fourth. But we only want to write in exponential form, and that's all we need to do. Okay, now we need to simplify this expression. Well, let's first, since we have this fractional exponent, we can use that and rewrite it in radical form. So let's do that first. Okay, so 4 is our index from here. and then we have 16x to the 8th. Now, like I said before, I find this form to be the most useful, where you put the parentheses on the outside of the entire expression and then raise that to the third. And I'm going to show you why. Okay, so what I could do is write this out 3 times because it's cubed, right? I could write 16, 8, x to the 8th, and I could write that 1, 2, 3 times. Okay, and then I could simplify each one of those. But why do that when I can just simply first focus on the inside of the parentheses, simplify that, and then after I'm done simplifying, then use this cube power. Okay, so let's do that. Okay, so next step. So first I'm going to break this 16 down. And you can use birthday cake if you'd like. Here I know that 2 times 2 times 2 times 2 is equal to 16, because 2 to the 4th is 16. And if you notice, the index is 4, so I need groups of 4. So that works out perfect. I have 4 2's. But now this x to the 8th, 8 x's, well, I need groups of 4, and I know I can get 2 groups of 4 in 8, so I'll change that by making it x to the 4th and x to the 4th. And each one of those x to the 4th is 4 x's. And so those will each be a group of 4. But don't forget, it says all raised to the power of 3, or cubed. So now, I have a group of 4 here, 1 here, and 1 here. Okay? So knowing that, a 2 will come outside, 1x will come outside, and another x will come outside. And if you notice, there's nothing left. After I've circled everything, there's nothing left. Okay, so the radical is going to go away. That 3 is not going to go away, but the radical will go away. So now I have 2, and I have 2 x's, so that's x squared. All of that raised to the 3rd power. And now, since I have the 3rd power applied to both the 2 and the x squared, it'll be 2 cubed. And remember, when you have an exponent outside of an exponent, we multiply. So that'll be x to the 6th. And I know that 2 cubed is also 8. So 8x to the 6th. Okay, now let's simplify these 2 radicals here. Now, I apologize. The computer doesn't recognize this little multiplication symbol. So this g is actually supposed to be a multiplication symbol. Okay, so this is actually the 4th root of x to the 6th times the 4th root of x to the 9. Okay, so don't pay attention to the g. G is meaningless. Okay, so now here, if you notice, I have a radical that, 2 radicals that have the same index. They both have the 4th root. If that is true, if both radicals have the same index, and they're being multiplied, like here, this is this one times this one, I can combine the radicals, or I can combine what's on the inside, and they can become 1. So now, this is x to the 6th times x to the 9th. Okay, which gives me a total of 15. X to the 15, or 15 x's. Okay, so again, I need groups of 4. So let's make groups of 4 until we get to 15. So one x to the group of x to the 4th. Okay, then another group of x to the 4th. And that's 8. And another group, and that's 12. And then I only have 3 left over, so I'll have x to the 3. Okay, so now I've got 1, 2, 3 groups of 4. And one group of 3 left over. So to complete this expression, I'll take out 1, 2, 3 x's, because of 3 groups. So that's x to the 3rd on the outside. And I still have a remaining radicand on the inside, so that x to the 3rd will remain inside. Okay, and there's my final expression, x cubed times the 4th root of x cubed. Okay. Okay, now we're going to simplify this one. Now this one's a little different because the indexes are not the same. This one is 5 and this one is 3, so a fifth root and a cube root. And again, I apologize because this g is not here. Remember, it's this times this. Okay, and the g doesn't exist. Okay, now here, because the indexes are different, I cannot combine the radicals. So I can't combine it like I did in this last step where I just combined the two. Okay, so now what I have to do is treat these like two separate expressions and simplify them separately. And then in the end, we can see what we combine. Okay, so first, I'm going to focus on the left side. Okay, so now we have a fifth root, and it's x to the 10. So I need groups of 5. So I have two groups of 5 there. Okay, so now let's go to the right. I have x to the 10th again, but now it's a third root. So I'll need groups of 3. So I have a group of 3, another group of 3, that's 6, another group of 3, that's 9, and then one more x. Okay, so now here I have 1, 2 groups, and over here I have 1, 2, 3 groups of 3. Okay, so now on the left, well, there's nothing left after we circled the two groups, so all I have is x squared because I have two groups. Okay, now on the right, looks like I have 1, 2, 3 groups, so 3 x's come out, or x cubed, but I still have x under my radical, and it's a third root of x. So now, what I can do is I have this x squared and x3 on the outside of the radical, so those can combine. So now this is equal to x to the 5th. And a common mistake I saw on the test, and I always keep on repeating myself, is don't forget your index. Okay, don't forget that in the end, because then we don't know if it's a square root, a third root, a fourth root, a fifth root, or whatever it is. Okay, there's your answer. Okay, so now we're going to simplify a radical that has a fraction within it. Okay, so again, the nice thing about radicals is that you can modify them just like we did before. You can both combine them like we did in this step, and we can separate them and go, in other words, the reverse. Okay, so this can be separated into the square root of 8 on the top and the square root of x to the 6th on the bottom. Okay, and just remember, when we don't have an index, it is always 2. So keep that in mind. Okay, so now what we need to do is break down each of these radicands. Let's start with the 8. Well, I know I need groups of 2, and 8 breaks down into 2 times 2 times 2. Okay, and then the x to the 6, well, I know that I can get 3 groups of 2 out of the x to the 6th. Okay, so now let's circle our groups. So here we have 1 group of 2 and then 2 left over. Here we have 1, 2, 3 groups of 2. Okay, we write this up here. So on the top, we'll take 1, 2 out, but we'll still have a 2 within inside our radical. And then on the bottom, 3 x's will come out, and that'll be x cubed. Okay. Another common mistake, what I saw on the test, let's actually show this, is I saw some of you guys write the x cubed, all of a sudden was added to the numerator, and then there was no denominator anymore. It was no longer a fraction. But when you take out those x's from the radical, they still remain in the denominator. Okay, so make sure that whatever comes out of the denominator radical stays in the denominator. Okay. Okay, now this next one, again, same idea. We can split both the numerator and the denominator. Or don't forget that index. That's the 7th times y to the 5th, and then 16 on the bottom. And again, let's simplify the top and bottom separately. So in the top, I know I have 7 x's, so I can get one group of 4 out of there. Then I'll have 3 left over. And for the y, I have one group of 4 there, and I'll have 1 left over. Okay, now on the bottom, I can break down the 16 into 2 times 2 times 2 times 2. And again, if you need to do a birthday cake to help remind yourself, then go ahead and do that. But these are a bit smaller numbers, so they're easier to recognize the prime factors. Okay, so now I've got one group of 4 here, one group of 4 here, and then on the bottom, I got a whole group of 4 and nothing left over. Okay, so let's rewrite this here. Okay, so on the top, 1x comes out, and 1y comes out, but then I still have variables remaining in the radical. So now I have x to the 3rd and y left over on the inside. And then remember, again, keep what's in the denominator in the denominator. And here I have a group of 4 2's, so, and nothing left, so it's just over 2. Okay, so again, same idea, split this apart. We'll start all these radicals that have fractions in them the same way. Split them up first. Okay, x to the 11th over x to the 5th. Now, if you notice, the indexes are 2. And on the bottom here, 5 is a prime number. So I can't break that down in any way to get a group of 2. So that presents a problem. This one I have to do a little bit differently because I can't break that down in any way. And the thing is, when we simplify, we don't want to end up with a radical inside or in the denominator. So we need to break this up in a way to help get rid of that. Well, in order to do that, I'm going to need 2 5's in order to cancel out that radical. So to get 2 5's, I'm going to actually multiply it times 5. Because remember, if I multiply it times the square root of 5. Because if I multiply 2 radicals that have the same index, again, just like we did back in this step, x to the 4th and x to the 4th, we can combine what's on the inside. So going back to this one, with that idea, if I multiply the same radical, I can combine the 5's on the inside. But again, as we do with any multiplying of fractions, we have to multiply the top and the bottom. Okay, so now what happens is now I have on the top 5, because now we combine the 5 and the x to the 11th, 5x to the 11th on the top, and on the bottom we'll have 5 times 5. Okay, so now let's go a little bit further on the next step and break down the numerator. Okay, so 5 times, let's see, we need groups of 2, so x to the 11th, I have a group of 2, another group of 2, which is 4, 6, 8, 10, and then one more, because we have 11. Okay, and then on the bottom, we just have our 2 5's. Okay, so let's get our groups of 2. So we have 1 here, 1 here, 1 here, 1 here, 1 here, nothing else. And then on the bottom we have one group. And that will get rid of our radical. That was the whole point of multiplying everything times, or the top and bottom times x to the square root of 5. Okay, in the top we'll have 1, 2, 3, 4, 5 x's come outside the radical. And on the inside we'll still have 5 in x. Now remember, the index is 2, so we don't need to write it, but just so for the sake of trying to remember, we need to always write it. I'll write 2 there. And it's not going to get you wrong if you do. And then here we have one group of 5, so 1 comes out, and then that's it. Okay, so here's another one where we're going to have just one group of, one 5 by itself on the bottom. Okay, so I'm going to go through this a little quicker. So now I'm going to start breaking down the top right away so that we can kind of save ourselves some steps. Okay, I have an index of 3, so I'll need groups of 3 on the top. So I have 3 groups of 3 for A. And then for B, I'll have 1 group of 3, 2 groups of 3, that's 6. 3 groups of 3, that's 9. And then it's 11, so we need to make sure that adds up to 11 B's. So 3, 6, 9, 11. Okay, and then on the bottom, we'll have the cube root of 5. Well, here I need 3 5s in order to cancel out. So now, not only will I multiply it times the cube root of 5 on the top and the bottom, I'm going to multiply it times 2 cube roots of 5. Because then, when I combine all those radicals, I will then have 3 5s on the bottom. Okay? And again, I'm kind of going a little bit on light speed, so I'm going to do all these steps at once. So here, I'll have a group of 3 A's here, 1 here, 1 here. Here's another group of 3 B's and a group of 3 B's. And then the 5s, I only have 2 5s on the top, so those won't combine. But on the bottom, I'll have 1, 2, 3 5s, so that will automatically cancel out. And that was the whole point of multiplying times those 2 5s to begin with. So we know those are going to cancel out. Okay, so on the top, I'll have 3 A's come out, 3 B's come out, and then remember our index, which is 3. And then on the inside, I'll have 2 5s, which equals 25, and then B squared. And then on the bottom, remember that we had the 3 5s, so then we're just remain with 1 5 that comes out. Okay? So now here, you're going to use those skills you used in the problem we did earlier where we had to graph the radical, and then you're just going to simply graph this line and figure out where they cross. Okay, so I'm going to kind of quickly go through this one because you've already learned how to graph a radical. Okay, so we'll make our table, and I'm going to do this for the radical first because that's the hardest one, the graph. Graph those. Okay, so -6 and 1, -5 and 2. Oh, whoops. Sorry about that. That's a little too high. Sorry, -5 and 2 there. I was like, that's a little too high. Okay, then -2 and 3. And 3 and 4. Okay, so our graph starts here and kind of moves up going that way. Okay, so now we need to graph this y equals 2x minus 2. Well, again, if you remember, this number, the second number, -2, is our y-intercept tablet. All right, and there is our point of intersection right there. And it looks like that point is at 3 and 4. Just to make sure in the test you get an exact point, okay? And to figure out what that point is, it should be in your table here. Okay, so you'll see that 3 and 4. So don't just guess, because you want to make sure it lines up correctly. So use a ruler. Okay, so now we're going to solve radical equations. Okay, one of my favorite. All right, so now the steps are, the first step is always the easiest. Okay, and we just got to recognize it. The first thing you want to do is raise everything to the power of the index of your radicals. Okay, so the index is 3, so I'm going to raise it all to the 3. Okay, so now what happens when you do that is it cancels out the radical. Why does it do that? Well, if I take 10 squared, oh, sorry, not 10 squared. If I take the square root of 10, and let's say I turn that into a, let's say I raise that to the second power. Well, now let's turn that into a exponential function, or exponential expression. Okay, so this will be equal to 10 to the 1/2 raised to the power of 2. Okay, now with, or actually I don't even need to write that way. Now remember, with the exponent on the outside, that is going to be our numerator, and then the index is our denominator. And then 2 over 2 is equal to 1. So we started with this, and we ended up with this. So that's why if you raise this to the power of 3, it makes this radical go away. Same idea. Okay, so now we just have 4x plus 3. Now, common mistake I saw on the test, you raise the power of the one side to 3, but you forgot about the other side. Remember, with any equation, you change one side, you got to change the other the same way. So now we got to cube this 3, which is equal to 27. So don't forget to change both sides of the equation. Okay, that was one of the most common mistakes I saw on the test. Okay, so now let's subtract 3 from both sides. I have 24 here, divide by 4. X equals 6. Now, with all these solving equations, you need to go back and check your answer. Okay, especially when we get to some of these problems where you end up with 2 solutions, because one of them most likely won't work. If you end up with one solution, it probably will work, but you always still want to check. Okay, so now plug it in. I get 24 plus 3, which is 27, and I know that the cube root of 27 is 3, so that works. Okay, again, raise the power of each side to the power of the index, so to 3. And don't forget, if there's a 2 here, include that 2 within those parentheses, because you're going to raise that power of that 2, and you're going to change this radical as well. Okay? And just remember, the 2 is being multiplied times this cube root. So it's this times this. All right, so now first on the left, well, that raising the power of 3 cancels out the radical. And then over here, we've got 2, it's going to be raised to the power of 3, so that's 8. And it was multiplication to begin with, so whatever was inside the radical is now multiplied times 8. Okay, so a common mistake I saw on the test with this one, either I did not see the 2 being raised to the power of 3, or we forgot that this was being multiplied times that same value of 2, or which is now 8. Okay, so now let's distribute that 8. 8x minus 8. Okay, so now let's isolate x. Now let's subtract x from this side and add 8 to this side to move the numbers to the left and the variables to the right. So add 8 here. Subtract 8x here. 14. And then 7x divided by 7. And x equals 2. And again, go back and check your answer. So now we'll plug in 2. Well, 2 plus 6 is 8. And then we'll plug in 2 over here. We'll have 2 minus 1, which is just 1. And then I know the cube root of 8 is 2. And then cube root of 1 is just 1 times 2 is 2. So boom, that's good. Okay, so now here, just remember we don't have an index. If there's no index, that means that's 2. So let's again raise everything to the power of 2. Okay, so now that makes this radical cancel out. Oops, not equal there. And now we have x plus 3 cubed, or squared. Now if you remember, Algebra 1, if you square a binomial, that means you have 2 binomials. Another mistake I saw on the test. You squared this and you thought that was equal to x squared plus 9. No, because it's equal to 2 of these binomials, like this. Okay? So if that's the case, then after I FOIL it, it's going to be x squared plus 6x plus 9. Okay? Now we have an x squared in the mix. Now remember, this is where you need to recognize. If you have an x squared in your equation, you need to put all the terms on one side. Okay? Because you're probably going to have to factor out a trinomial and figure out what makes it equal 0. Okay, so now what I'll do is subtract 2x and subtract 14 from this side so that this side will only have 0 on that side. We want to set everything equal to 0. That goes away, that goes away. So now we have 0 equals x squared, and then 6x minus 2x is 4x, and then 9 minus 14, well, that'll be negative 5. So now we have a trinomial here. With that in mind, we have to factor it so that we can figure out what makes it equal 0, or what makes it equal this 0 in particular. That will tell us our next step, or reveal our solutions. Okay, so I know that, let's see, two numbers that multiply to negative 5, but add up to 4. Well, let's see, I know I'm going to have to do 5 and 1, because that's the only way I can multiply 5. And I'll have to make 5 positive and 1 negative in order to get a positive 4. Okay, so now remember, x is a liar, so our solutions are x equals negative 5 and x equals 1. Now again, this is where it becomes really important to check your answer at the end, because if you don't, you're going to get this problem wrong, because it's most likely one of the solutions doesn't work. So I'm going to go ahead and plug in the 5. So now 2 times 5 plus 14, and then equals 5 plus 3. Okay, so 10, this is 2 times 5, which is 10, plus 14 is 24. So now square root of 24 equals 8. And I'm pretty sure the square root of 24 does not equal 8. Okay, because 8 squared is 64, not 24. Okay, so that one does not work. So that means negative 5 does not work. So let's now check 1. So now 2 times 1 plus 14. And you want to check both, because you never know. It might be no solution at all. Okay, so now 2 times 1 plus 14, oops, sorry, that's 16. And then 1 plus 3 is 4. Well, I know the square root of 16 is 4, so that is good. So now our only solution is just x equals 1. Okay, so now on this one, again, the approach is still the same. I got to recognize that the index is 2 here, so then I'm going to raise both sides to the power of 2, or square both sides. Okay, so on the right side, again, that will get rid of our radical, and we'll just have 4x plus 10. On the left side, remember that a binomial squared means that you're going to have 2 of them. So 2x plus 5 times 2x plus 5. Okay, so now I need to FOIL or multiply that out. Okay, so the first term, 4x squared, 2 times 2x, and then 2x times 5 is 10x, and then add the middle term, 5 times 2x, that's another 10x, so those 10x plus 10x is 20x. Actually, I'll do this one step at a time so you guys can see it. So 2x times 5, 10x, and then the middle 5 times 2x, another 10x, and then the last 5 times 5 is 25. And let's combine like terms on each side. Well, here I've got a 10x and an x and x here, and that'll become 20x. That's how I got 20 in the last step, in case you were wondering. Okay, now, again, recognize the fact that I have an x squared term in here, this 4x squared. So if I have a 4x squared in there, then I need to get everything to that side. Okay, so that means that this 4x needs to go. So I need to subtract 4x here, and this 10 need to go. So I need to subtract 10 here. So then that means I'll subtract that 4x here, the 10 here. These will cancel out. Now I'll have 20 minus 4x. 20x minus 4x is 16x. And then 25 minus 10, well, that will be 15. Okay. Now I need to factor that. Okay. So in order to factor this, well, it looks like I'm going to have to think this one out a little bit. Okay, so let's use the x for this one. So first term times the last term, 60. 4 times 15. And then our middle term here. And then let's go down the list and see what numbers multiply to 60. Let's see, 20 times 3, 15 times 4, 12 times 5, let's see, 10 times 6. Oh, 23, that doesn't work, but I know 10 and 6 will work. Okay. So there we go. So now I got to do my x box, because remember the leading coefficient is bigger than 1, so I can't just go straight to making my parentheses. So I make a box. First term here, last term here. Again, this is all review. You need to look back in your notes in Unit 3 on factoring with the x box. Okay, so I know that in order to get 4x squared, it's either going to be 4x times 1x, or it's going to be 2x times 2x. Let's try 2x first, just because I feel like it. And let's see, what times 2x equals 10x? Well, that'd be 5. And what times 2x equals 6x? 3. Well, that works. Okay, so now our factors are going to be 2x plus 5 and 2x plus 3. And now, well, we've got a 2x plus 5 and a 2x plus 3. Well, and we have to figure out what's going to make this equal 0. That will give us our solutions. However, it's not as obvious. Okay, it's obviously going to have to be some fraction. So what I'm going to do is take this 2x plus 5, set it off to the side, and I know I need to figure out what's going to make it equal 0, so just make it equal 0. And then subtract 5 from both sides. 2x equals negative 5, and then divide both sides by 2, and then x equals negative 5 over 2. Okay, and then over here, 2x, do the same thing, set it equals 0, and then you should see right away that if I have negative 3 over here, oops, sorry, then I'm going to be dividing both sides by 2, so I'll get negative 3 over 2. Okay, still not done. You got to check your work. This is probably the most lengthy problem that you'll see on the test. Okay, so let's check our work, and I'm going to do that in green. Okay, so let me move up a little bit so you guys can see it all. Now, let's check this negative 5 over 2. Okay, so our problem was, what was it? 2x plus 5 and the square root of 4x plus 10. So plug in the negative 5 here for the x, plus 5 equals the square root of 4 times negative 5 over 2 plus 10. Okay, so now over here in this first one, well, I know these 2's will cancel out, so that'll just be negative 5 plus 5. Oop, that's 0. Okay. And then over here, well, I have a 4. I'll put that over 1. If I multiply across here, I just did 2 different ways. That will be negative 20, because 4 times negative 5 over 2 plus 10. And then if negative 20 over 2 is 10, actually, let me just do this real quick. Negative 20 over 2 is negative 10. Negative 10 plus 10 is 0. And then the square root of 0 is equal to 0. Okay, now let's do the same thing with the negative 3 halves. Okay, so let's plug it in. So now 2 times negative 3 over 2 plus 5. And the square root of 4 times negative 3 over 2 plus 10. Okay, over here again, 2's cancel out, so I have negative 3 plus 5, which will equal positive 2. And then over here, I'm going to do this a little different this time. Well, 4 over 2, if the 2 will cancel on the bottom, and I'll be left with 2 on top. And then 2 times negative 3 is negative 6 plus 10. And negative 6 plus 10, well, that's 4. So the square root of 4 is equal to 2. So we're good. Okay. Okay, last problem. Okay, so now A little bit different here. So now we need to recognize that this expression here over here is in exponential form. So in order to solve it, let's put it back in radical form. Okay, so remember, the 1 is our power and the 3 is our index. Okay, so the index is 3 and the power is 1. So we'll just write 3x plus 1. And since the power is 1, we don't really need to write that in because 1 doesn't really change anything. Okay, and that equals 2. Now we're going to solve it the same way like you did before. So raise it to the power of the index, which is 3, on both sides. Okay, and then that takes away the radical on this side. And then over here, well, I know 2 cubed is 8, but then if I multiply negative 2 3 times, I still end up with a negative. So that'll be negative 8. Okay, so now just solve the equation like we did before. Minus 1 here, minus 1 here. 3x equals, negative 9. And divide by 3. X equals negative 3. So the trickiest step is just to recognize that you need to convert this back to radical form. And once you do that, then the steps are pretty straightforward. Okay, and there's your answer. But again, we need to check it. So instead of plugging it into this original one, well, I guess, yeah, we could plug it in the original. It doesn't matter. Okay, so let's plug it into the original. That's always the safest thing to do. Okay, so I'm going to plug in the negative 3 here, plus 1, raised to the third power, equal to negative 2. Okay, so now negative 3 times 3 is negative 9, plus 1 would be negative 8. Be negative 8 raised to the 1/3. And then if I put this back in radical form, well, that's the cube root of negative 8. And I know the cube root of negative 8 is negative 2. Okay, because negative 2 cubed is negative 8. We just figured that out over here in the first step. Okay, so that answer is good. Okay, so remember, keep all your answers on one worksheet. Sorry, not one worksheet, on a sheet of paper, lined paper. Okay, and then bring that in when you are ready for the test. If you're in my class, you're going to be going over a few problems with me on whatever you need work on. That may only take like 5 or 10 minutes. You may only have a couple questions. You may need to sit down with me for like a half hour or more, depending on what you're unfamiliar with or what you are familiar with. Okay? All right.